Back to Balvigan Bharti with Avilash Sarkar. They are moving on to the problem number 45 in fluid statistics. So this problem, uh, problem number 45, it says a ball whose density is 0.4 into 10 to the power 3 kg per meter cube falls into water from a height of 9 centimeter. To what depth? To what depth does the ball sink? Does the ball sink? Okay. So this is in situation where, if I can assume, this is the layer of water from height, a ball is being dropped, and after dropping here you will move and it will stop somewhere here. Means I mean to say ball will stop somewhere here after crossing some distance. Let's say this is h, this is already said to be 9 centimeter. Now 2-3 things which is not said, even though this kind of that drop and going inside and sinking somewhere and stopping, this is not happening in one shot, because while it is going down there is a changing in the potential energy, and due to that it may somewhat bounce back, but at least it will stable somewhere. So we are thinking of that situation where it will be stable there and it will stay at some height, okay, after being sunk. So what would be the case? Now from there it has dropped. While it is touching, this situation will come when it will just try to touch the surface, it will gain some velocity. This is the first case, this is the first position, and this is the second position for them. There we can assume there is no potential loss or due to the air friction and all that. So that we are not considering. We are thinking it is a unique and ideal case. Okay. So whatever velocity due to the height you will gain, it will reach air up to this. So for that, what is the case? For the case 1, the height, we know this is v square minus u square. As you have already covered the kinematics. In kinematics, we know the gravitation and the motion against gravity, that is the projectile part, it is 2gh. Okay, this is the case. So v square is the velocity here, the final velocity, so v square, u square is the first velocity is equal to 0, final velocity v is equal to, we have to find, so this is minus 0 and 2 g and h is equal to 9. So this is ultimately v square is equal to 80 g. So v is equal to under root of, so this is my first equation. Second case, when it is going into the water, so water has some density that is equal to 10 to the power 3 meter per kg per meter cube. Due to that it will get some resistance and it will slow down and it will stay somewhere. Okay, if this is h, again this will be applicable from second case. The same equation v square is equal to, because this is also against the gravity, u square. I am just taking the Traditional equation, this is not anything specific v or u. Traditional equation I am using, so I am writing the same equation again. What is v? The final velocity here. This is for the second journey, this is your initial velocity, this is final velocity. The final velocity when it is stopping, so this will be the 0 minus what is u is v here. V square is equal to 2g and h is equal to the height that has to be considered. Okay, so this is minus v square is equal to 2g into h. Initial velocity. The initial velocity is nothing but minus under root of 18g, that is equal to 2gh. Okay. Sorry. Now this, because v square is equal to only gh. So from there h is equal to how much? Minus 9. H is equal to 2g 9 into 2, 2g minus 9 is equal to h. But sorry, this equation will not, because this equation only applicable when there is no resistance. So I cannot use this equation because there is a resistance. So this only happening due to the gravitational force. This is the weight. But as because this is dipping inside, so there is the force which is acting, if I say F is equal to the weight of the ball minus the buoyancy. This will be the effective force. So for that the reduction will in the velocity will be there. Okay, so if it is the case, then weight of the ball is the weight of the ball is equal to mass into g. Okay, minus this when sinks down in the water, this will give you the mass divided the density of the water is the volume into the row of water, density of the ball, this is density of the ball, row of water into g. Okay, this is the volume rho, the buoyancy force rho into g. This will be the case. Okay, the buoyant force that will resist, because when it is there, the force balance is there. This is weight. At any point of time, it is buoyant force, and the residue force it will give it is a this is a momentum. It is always there. This momentum is causing it to. So and the force balance is that this force is equal to the force due to the momentum. Okay, so this is force due to the mass of the ball into the acceleration, or the acceleration is created here up to this. So mass into acceleration is the force. That force is acting downward. This force is nothing but this force is balancing. How long it is will be more, that will cause it to bring it down. So this force direction will be the force due to the conversion of potential energy into the kinetic energy. This kinetic energy here, it will create a force to come down. The force is equal to mass into acceleration. This mass into acceleration is nothing but force into the displacement. This force into displacement, if I take this up to h will go, this will be the kinetic energy half m v square minus half m u square. U square will be 0 here, square. So half m v square is equal to mass into this. So this will be the v square by 2 equal to mass into g into mass. So mass is cancelling. and this will be the v square by then this is equal to g. If I take out, this will be the 1 minus rho of water by rho of ball. Fine. So v square we are already having 18 means 9g. V square means equal to 18g by 2 9g. So g will be cancelled out with 9. This is equal to and this is equal into h multiplied by h. So this will be the case. So now this multiplied with h again. Okay. So this will be the equation. Now 1 minus rho of water is equal to 1. So 1 upon 0.4 with the case into h. So now this is equal to h is equal to 9 into 0.4, and this will be 0.4 minus 0.6, because 0.4 means 0.4 go up, 0.4 minus 1, that will be 0. But that will be a negative sign will be there. One negative sign will come here. Okay. So now this is equal to minus. This will go 2 2 the 2 3 3 3 the, so that is equal to minus 6 centimeter. Why minus is coming? Because this is going below the surface level. This is negative distances will cover, so automatically that will come minus 6. Understood? So my equation for the second, this is first equation. Second is the kinetic energy converted, and this kinetic energy being loosed due to the force acting. Because when it is losing, that means the buoyant force, and because weight will be always be same, buoyant force is the upthrust is changing. Upthrust is V. Upthrust is changing due to the upthrust is always there, but the kinetic energy, as because there, this effect of the force, it is slowly making it slower. Means that the force buoyant minus W, if I say, because that I cannot presume that buoyant force is more than the W, as because it is reducing, there definitely the buoyant force is able to stop the weight. But that already due to this drop, I got some kinetic energy. This kinetic energy is changing into the force. If I say the W minus, this is the resultant will be the W downward and V upward. The resultant is W minus V, this force into the distance. This will give you same energy. This will this kinetic energy is changing into the potential energy. So energy balancing you are doing. So half mv square minus half mu square. U square will be 0, because other part I am not writing. This is half m u square. So u definitely is 0. So this part is 0. So half mv square is equal to the force into the displacement. So that is also again a work. Work is nothing but the energy, rate of doing energy, whatever. So the time is same for this all cases. So time I am not considering. So the change in energy is changing energy. Changing kinetic energy, change in kinetic energy is equal to change in potential energy. Okay. So the kinetic energy change is half mv square, force into displacement. So from there I got this much. So h is nothing but 0.9 into 0.4, and below this we calculate 0.6, but there is a negative sign. Okay, so that means whatever thing, whether you are going down, that is negative height is coming, or else as because it is stopping, so that means the whatever the force acting on that ball during that movement, it is buoyant force, but the and the self weight. So buoyant force must be high than the weight, otherwise it won't stop, it will go on moving if it is downward force. So that shows that buoyant force is, but I have taken the reverse one, so that's why it is coming negative result. So that means buoyant force is causing to overcome the self weight and it is stopping. Understood? So this is the case. From that height I can calculate. So I'll move on to the same next problem. Six. A rectangular block five centimeter cross 5 centimeter cross 10 centimeter if floats against 5 centimeter vertical against 5 centimeter vertical if floats I have to change the language because the language is given not what he said. The rectangular block this if floats against 5 centimeter vertical, then again he has said against. I'm not changing the language because in the exam maybe the same language may come. 10 centimeter vertical what changes occur in the water level? What changes occur in the water level? So why I want to change the language? Change because everything is monotonous like the language. Instead of a rectangle block, this it floats with this 5 centimeter vertical against 10 centimeter vertical. I want to make it like that, but anyhow that question is given like, but understanding is that if a block is there, this is the water surface, this is a block whose dimension is, if I say in the free diagram view, this is 5, this is 5, let's say this is 5, this is 5. So the cross section, I mean one side it is this one and other side it is bit longer, not that much if we do the proportionate one. So this will be something like that. So this side is your 10 centimeter, this is your 5, this is also 5. So the question mean to say, if the situation is that this is the first one is 5 centimeter vertical, so the side which is will be vertical will be 5 centimeter, like that it is floating. Okay, fine. So this is your 5 centimeter of this block. In the second case it is floating with 10 centimeter vertical. So this is your 5 centimeter, this is your 10 centimeter. Now in which case the level of the water will be high, because if I say this is H2, this case this is H1, so H1 and H2, what is the relation, whether they are same, they are different, and what that. Now for any floating, the basic equation is that the weight of the object and the water dispersed the buoyancy will keep it floating. Okay, this is the case. So weight of the object is equal to the buoyant force. So weight of the object is the volume of the object into the rho of the object. G as because it is both side is not contributing, and this is the volume of the water displaced into the rho of water. And second case, if I say the weight of the object V0 rho 0 will be same, and if I assume this is a different volume dispersed V2 into rho, this will be the case. Now one can see this is true, this is also true. If both the equations are true, so their left hand side is equal. So what could be the case? V1 must be equal to V2. So there is no ambiguity, because if this is true, V1 must be equal to V2. So whatever way you would just put the object, it will not disperse more than the same volume. So that means it is very much misconcept. If I think the longer side, if it is zip, it will disperse more water. It will disperse whatever is needed to float it, that much only. Means the V1, if it is this case also it will be V1. So whatever we will keep, if it is floating, not it is moving into the water, the buoyant and the weight will equalize that, and from there you can say both the volumes are same. So if the disbursement of the volume is same, so then H1 is equal to H2. This is concluded. Understood? Okay. (47) Okay, I will keep it for the next episode, because this will need some time too, because I have to come one more problem with that. It will take some time, what I understand. So I will move on to the next episode with this problem. So thank you for now.